So we will next go on to Rafael Riaz from the Universidad de Concepción in Chile, talking about the possible role of fragmentation accretion on the stellar initial mass function.
Yes, okay. Rafael is not here also?
Yes, I'm here. Can you hear me?
He's here. There he is.
Yes, perfect.
Can you hear me?
Yes, it can hear you.
Yes, it's okay.
Okay, hello everyone. This is Rafael Riaz from University of Concepción, Chile. And my work is actually addressing whether the stellar initial mass function is actually universal or not. It's always under debate whether the universality is there or not. So we try to address this particular phenomena of a stellar population with the help of the two fundamental regimes in any star-forming gas collapsing. These two regimes are the fragmentation and the accretion-dominated regimes. So we try to address this. A quick concept of the stellar initial mass function is that whenever a new population of stars coming into existence, it always comes with some mass distributions. High masses are small in number, while the low masses starts increasing up. And when you reach to a certain level of low masses, if you go beyond that, the number of stars again starts decreasing. So that's the stellar initial mass function, what we talk about. Next slide, please. So to address this, actually, we consider the cosmic microwave background radiations. And we consider this particular aspect as the dominant source, which can affect the stellar environment and regulate the thermal conditions prevailing in star-forming regions. And we try to analyze the CMB contribution towards the star formation, and hence it may regulate the stellar masses coming into any population. So what we did is we try to consider 5 models, starting from 10 Kelvin to 50 Kelvin as initial temperature states of these collapsing clouds of gas. And when we say 10 Kelvin to 50 Kelvin, we actually also cover a range of redshift from somewhere around 2 to 17. With this, it means that we actually try to cover a range of redshift, which means a cosmic stellar formation history. And we try to see whether the cosmic microwave background was really something that regulate the star formation. And since the collapse of a gas is actually following the thermodynamics, so to carry on with the thermodynamics, to follow this thermodynamical feature of the gas collapsing, we followed the barotropic equation of state. And if you see on the left for the 10 Kelvin gas, which is the final state of the collapse of our simulations, we come to know that if the gas is lower at the initial temperature and it starts collapsing, we found that there are quite a number of stars coming into existence. But on the right-hand side, which is the 50 Kelvin core, which mimics the high redshift environment, we found that not many stars coming into existence, but whatever coming into existence, they are more massive in terms of their masses involved. So that's the very first conclusion, that in a young universe where the temperature was quite high, it's difficult for a star-forming gas to attain lower temperatures as initial temperatures. And when these star-forming gases start collapsing, they actually form more massive stars than their counterparts, which is the present-day star-forming conditions, where you can have 10 Kelvin gas as the initial temperature of the gas cloud, and then it starts collapsing, forming quite a number of stars, but mostly they are low in masses. Can you go to the next slide, please?
And we are in our last minute.
Okay. So we try to follow the mean masses of the entire distribution of all these 5 models. And we come to know that if you reach to a specific star formation efficiency, which is around 5% value, you see that the more higher temperature environment, initial higher temperature environments, they are going to yield more massive stars. The green pattern is actually the high redshift environment, more thermal agitation is there, and they are producing more higher mean masses. whereas their counterpart, which is the red or the blue one, they are forming masses for the stars very low. So the star formation efficiency is also very critical when you try to understand the CMB contribution towards the stellar initial mass function. You can go in much detail if you follow my presentation, which is already a recorded one. That's all. Thank you very much.
And thank you very much. And Cesar, the remaining two speakers are not here today.